Okay, so hi there, folks. We're going to continue with our talk in the second Brother Dartez Math Lecture Series in the Vedic Maths Essential, and we are on the part 5, 5.3 to be exact. This is the second video for part 5, and we're going to extend in the just a recall for part 5. We have learned how to do the general case multiplication in 2 digits, that is making use of the sutra vertically and crosswise, and we also have learned in the second part of that first video about the application of bar numbers. Here, we're going to extend, instead of 2-digit numbers strictly, we're going to extend it to 3 digits and beyond. I think I can just give you one example of the 4 digits, but I'll just let you see the overall formula in how to apply this vertically and crosswise all across in n digits. So let's start with 3 digits, shall we? So multiplication of 3-digit numbers, making use of the Pigvaya. Okay, so we have steps. Just like in our 2 by 2 numbers, that is 2-digit numbers multiplication, we have 3 steps. Here, since we extended for 3 digits, we're going to extend the steps likewise. So first, imagine this 3 dots to be the first 3-digit numbers, and then this will be the dots here will be the second 3-digit number. So if we're going to multiply 3 digit by 3 digit, the first step will be multiply the hundreds place first. Okay, that will be the first step. Next is we're going to multiply vertically the hundreds place by the tens place of the other number plus the tens place of the first number multiplied by the hundreds place of the second number. So that's step 2. So just like in our 2-digit multiplication, the third step will be the one which is quite makes it very crosswise. In fact, it looks like this. This is our crosswise approach. This is hundreds place of the first number multiplied by the ones place of the second number plus the tens place of the first number multiplied by the tens place of the second number plus the ones place, ones digit, times the hundreds digit of the second number, and then get the sum. And then that will be our third step. Okay, quite big, but we can do that. Okay. Fourth step will be the opposite of step 2, crosswise again. Tens digit multiplied by the ones digit of the first step plus the ones digit multiplied by the tens digit of the second place. And then the step 5 will be clearly as ones times ones. So let's take a look at this example. This one over here. We have 3, 4, 2 times 1, 3, 4. So let's write it down. 3, 4, 2. I'll just put some big spaces there. Times 1, 3, 4. Again, 3, 4, 2 times 1, 3, 4. Let's do this. First step, hundreds by hundreds. 3 times 1 is 3. Second step is 3 times 3 is 9. 9 plus 4 times 1. That is 9 times 9. 9 plus 4 is going to give us 13. 1 as a carry there. Next step will be the step 3. 3 times 4 is 12. Let me write that down. 12 plus 4 times 3 is still 12 plus 2 times 1 is 2. So that's going to give us 12 plus 12 plus 2. That's going to give us 26. So this will be 2 will be carried here, and then 6 will be here. That's 26. Next is we have 4 times 4 plus 2 times 3. 4 times 4 is 16. 2 times 3 is 6. 16 plus 6 is going to give us 22. So that's 22 over here. And then lastly, we have 4 times 2 or 2 times 4. That's going to be 8. Okay, let's fix the carries. What we have is 4 here. 3 plus 2 is 5. 6 plus 2 is 8. And then copy off the remaining 2 digits. That is 45,828. And that's our answer for this example. Okay, so 342 times 134 is going to give us 45,828. All right. So hopefully you got that example. Don't worry, I'm going to give you one more example. You can pause the video, you can repeat it as many times as you want so that we can get the pattern. All right. Let's do the next example. We have 504, or rather, yeah, 504 times 321. 504 times 321. So let's do that. 504 over here. I'm going to make the spaces a little bit wider. 3, 2, 1. So let's do this. First step, 5 times 3 is 15. Next is 5 times 2 plus 0 times 3. So 0 times 3 is 0. 5 times 2 is 10. So we're going to put 1 here as a carry. Next step will be 5 times 1 is 5. Plus 0 times 2 is 0. Plus 4 times 3 is 12. So 5 plus 0 plus 12 is going to give us 17. So 17, put it here in the middle number, 1 as a carry, 7 as a number here. Next is 0 times 1 is 0 plus 4 times 2. So it remains to have 4 times 2, which is 8. And then lastly, 4 times 1 is 4. So let's work on the carries. What we have is 1, 6, 1, 7, 8, 4. And then that's our answer for 504 times 321. So 161784. Okay, hopefully you got that pattern again. And that will be our last example here. What we're going to do next is I'm going to let you answer this on your own. So this is 413 times 523. Making use of the sutra, vertically and crosswise, apply this pattern here you can see above, and then answer. You may pause the video, or you may play with this, which will give you 30 seconds to answer it. Okay. Okay, you should be in step 2 right now. Beginning step 3. Okay, make sure that you don't do some bad steps. You should be in step 4 right now. All right, step 4 seems to be easy. And then step 5, you should be fixing now the carries. And then 3, 2, 1, and then let's have it in the next part. So this is our answer. 215,999. Okay, 215 times 999. So how did we end up with that answer? Let's show it. 413 times 523 is going to give us what? So step 1, 4 times 5 is going to give us 20. Step 2, 4 times 2 is 8, plus 1 times 5 is 5. So 8 plus 5 is going to give us 13. And then we have 4 times 3 is 12. Let's do this mentally. 4 times 3 is 12. 1 times 2 is 2. And then 3 times 5 is 15. So 12 plus 2 is going to give us 14. 14 plus 15 is going to give us 29. And then what we have is 1 times 3 plus 3 times 2. 3 times 2 is 6. 1 times 3 is 3. So 6 plus 3 is going to give us 9. And then 3 times 3 is 9. So let's fix the necessary carries. What we have is 2, 1, 5, 9, 9, 9, which pretty much the same with our final answer here. Okay, so this is the end for the 3-digit numbers. What we're going to do is we're going to extend this pattern to 4-digit numbers. What I'm going to do is just to illustrate you one. How we do this, making this as one example will be quite quite challenging, but let's see if I can do that. So step 1 will be this. So I'm going to write here step 1. So imagine our 2-digit by 2-digit gives us or produces us 3 steps. 3-digit by 3-digit gives us 5 steps. So you can imagine 4-digit to be more than that step. So step 1 will be, imagine this as our 4-digit number. So step 1 will be multiplication of thousands to thousands. Step 2 will be something like this. So this is the first crosswise step. What we're going to do is we're going to multiply thousands by hundreds plus hundreds by thousands. That's step 2. Step 3 will be similar, to what we did in the 3 by 3. So imagine this to be this number, ones, thousands, hundreds, tenths, ones. We're going to multiply thousands by tens, hundreds by hundreds, and tenths by thousands. That's step 3. So let's imagine step 4. So step 4 will be all of them multiplied together. So what we have is thousands, hundreds, tens, ones, thousands, hundreds, tenths, ones. Multiply thousands by ones, hundreds by tenths, tenths by hundreds, and ones times thousands. So this is step 4. Let's continue. Step 5. Imagine this, and this. Then you continue this. This will be opposite of step 3. So hundreds by ones, tenths by tenths, and ones times hundreds. That's step 5. Step 6 will be the opposite of step 2. So this will give us um, tenths by ones and ones by tenths, like this one. Just add the products. And then lastly, step 7 is going to give us ones by ones. Let me just illustrate that. Multiply ones digit by ones digit. So that will be our multiplication of a 4-digit number by a 4-digit number. Um, I'll let you create one example for yourself and try out on a calculator if it works. Let's say, let's create one example here, shall we? So, for example, let's recreate, what do you want? Let's try small numbers, only small numbers. Let's do 2, 1, 3, 2. We multiply this by 3, 2, 1, 1. Okay, let's make it simple. Okay, so 3, 1, 2, rather 3, right, so sorry, 2, 1, sorry, 2, 1, 3, 2 times 3, 2, 1, 1. Okay, 2,132 times 3,211. So let's try and then make use of this steps over here. So I'm gonna need a little, an even more bigger space here. Let me erase this, sorry. What we need is 2, 1, 3, 2. Multiply this by 3, 2, 1, 1. So obviously these numbers are quite small, just to illustrate that the sutra works. Okay, 2 times 3, it's going to give us 6. That's step 1. Step 2 will be this: 2 times 2 plus 1 times 3. So 2 times 2 is 4, plus 3 times 1 is 3. 4 plus 3 is going to give us 7. Okay, next is 2 times 1, this one here, plus 1 times 2. So this is 2, plus 2, plus 3 times 3 is 9. So we have 2 plus 2 is 4. 4 plus 9 is going to give us 13. So 1 as a carry, 3 over here. Okay, so the middle step is the one which is kind of heavy. 2 times 1 plus 1 times 1 plus 3 times 2 plus 2 times 3. So let's write it over here. 2 times 1, thousands by ones is 2. 1 times 1 is 1. 3 times 2 is 6. And 2 times 3 is also 6. That will give us 2 plus 1 is 3. 3 plus 6 is going to give us 9. 9 plus 6 is going to give us 15. So that's 1, carry 5 over here. So let's do step number 5 right now. 1 times 1 is 1, plus 3 times 1 is 3, plus 2 times 2 is 4. So 1 plus 3 is 4. 4 plus 4 is 8. Okay, so that's our 8. That's our answer there. Next is we have 3 times 1 plus 2 times 1. So 3 plus 2 is going to give us 5. And lastly, 2 times 1 as step 7 is going to give us 2. Clean the necessary carries. So we have 6, 8, 4, 5, 8, 5, 2. And this is our product when we multiply 2,132 by 3,211. So the answer is, what is this? 6,845,852. And that is correct. You may check that with your calculator. I'm pretty sure it's correct. Okay, so that's the power of Vedic mathematics. When we extend the general case into 3 digits, 4 digits, and so on. Which is beyond what is beyond our lesson is, in which I haven't really given you an example. Say for instance, we're going to multiply a 3-digit number by a 2-digit number. We're going to make use of a moving multiplier method. Maybe I will need to make another video for that, because it's beyond our parts here. But take note that we're not only limited in multiplying 2-digit by 2-digit, 3-digit by 3-digit. We can multiply 4-digit by 2-digit, 4-digit by 3-digit, and so on. So that's a general case that we will make use of the moving multiplier over there. So I'll preserve that, or I'll reserve that to the next video, for everybody to look at. So next is we're going to apply this, extend this application into algebraic products. So the vertical and crosswise method of multiplication described and shown before can also be applied in multiplying polynomials in one line. For instance, we are asked to expand this. Okay, say for instance we're asked to expand this part here. So how do we do that? We're going to write it simply as 2x plus 4 multiplied by 3x minus 5. So what we're going to do is we're going to make use of the vertical and crosswise, making use of the two-digit approach. So 2x times 3x is going to give us 6x squared. 2x times minus 5 is going to give us minus 10x, plus 4 times 3x is going to give us 7x. So minus 10x, okay, plus 7x is going to give us minus, sorry, 4 times 3 rather. So 4 times 3 is 12. My bad. Not 7. I just added it. Okay, let me do another line. So again, 2x times negative 5 is going to give us negative 10x. And 4 times 3x is going to give us plus 12x. My bad. So 10x plus minus 10x plus 12x is going to give us plus 2x. And then lastly, 4 times minus 5 is going to give us minus 20. And this is the expanded trinomial version of these factors here, of these two binomials here. So this is the quadratic trinomial that we have. So we should show first how this works in algebraic products. Actually, what we have done here is actually the FOIL method written in one line. Okay, this is the FOIL method written in one line. Take note that there is an important principle which has a harmonizing effect relating to algebra and arithmetic. By substitution of x equals 10, we can turn an algebraic expression into a number and vice versa, a number into an algebraic expression. So for instance, when we write the number 652, it may be treated as 6x squared plus 5x plus 2 for x equals 10. That's why we can make use of the vertical and crosswise both in algebra and arithmetic, because we can just imagine that these x's are equal to 10, and then all it can be converted into a number. And if it is converted into a number, we can apply the sutra as in algebra as well as in arithmetic, or in arithmetic as well as in algebra. That is why the sutra, vertically and crosswise, together with other algorithms, can be applied both in the two branches of mathematics, algebra and arithmetic. All right, so let's see more examples of this, shall we? So let's have x plus 3 times x minus 7. So x plus 3, sorry about that, x plus 3 times x plus 7. So let's write it down. X times x is going to give us x squared. 7x, or rather, x times 7 is 7x, plus 3 times x is 3x. So 7x plus 3x is going to give us 10x as our middle term. And 3 times 7 is going to give us 21. And this is our expanded trinomial. For this example, what we have is 3x plus y. 3x plus y multiplied by 4x minus y. So we apply the sutra. 3x times 4x is going to give us 12x squared. 3x, the crosswise approach, 3x times minus y is going to give us minus 3xy, plus 4x times y is going to give us 4xy. So minus 3xy plus 4xy is going to give us plus xy only. That is plus 1xy. And then positive y times negative y is going to give us negative y squared. And that is our answer for this example over here. Okay, as you can see, it's cleaner. It makes use of one line, and then we're done. All right, more examples for you guys. Expand 5x minus 1 times 2x plus 3. So how do we do that in one line? 5x minus 1 multiplied by 2x plus 3. 2x plus 3. So a vertical method, vertical step, 5x times 2x is going to give us 10x squared. 5x plus times 3, rather, 5x times 3 is going to give us 15x plus negative 1 times 2x. So imagine this is going to become 15x minus 2x. Okay, because this becomes negative because of the negative 1 here. So this becomes 15x minus 2x is going to give us positive 13x. And then lastly, negative 1 times positive 3 is negative 3. And this is our answer for this example over here. Next is expand quantity 5x minus 4 times quantity 3y minus 2x. So this will give us 5x minus 4y times 3y minus 2x. We can make use of by the commutative property. We can just align both x's so that it will be easy for us. Maybe we can do it something like 5x minus 4y negative 2x, align the x's, plus 3y. So let's erase this part so that we won't get confused. Okay, and then we'll apply the sutra. 5x times negative 2x is going to give us negative 10x squared. Next is we have 5x times 3y is going to give us 15xy. Let me write it here so that we won't get lost. 15xy plus negative 4x times negative 4y times negative 2x is going to give us positive 8xy, right? So we're going to sum them up. 15 plus 8, since they are like terms, this becomes 23xy. Okay, times lastly, for the last step, negative 4y times positive 3y is going to give us negative 12y squared, since we have y times y. And this is our answer for this example here, which is the second half. Okay, so in this last exercise, what we're going to do is I'm going to give you some exercise. You can pause the video if you want. You try to answer this using the sutra, and then I can give you 30 seconds to answer it. Okay, so you should be done with number 1 right now. Okay, starting with number 2. In the middle of number 2 right now. Okay, we're now number 3. Okay, finishing number 3. Okay, checking the answers, and then 30 seconds is done, and then I'm going to show you the answer next. So these are the answers. I think I'll try to fit the solutions here. So let's try. So 2x plus 3 times 3x plus 5. This will give us 6x squared. Crosswise, 5x times 5 is 10x, plus 3 times 3x is 9x, so that's going to give us 19x. And then lastly, for the next step, 3 times 5 is 15. 19x. So this is our answer, which is correct. Number 2, we have 3x minus 2 and x plus 7. So this will give us 3x times x is going to be 3x squared. 3x times 7 is 21x plus negative 2x. So that's going to give us plus 19x. 21 minus 2. And then 2 times negative 2 times positive 7 is going to give us negative 14, which is pretty much the same here. And for number 3, we have, I'm going to put it here, 5x plus 1 times 3x plus 4. So this is going to give us 15x squared. Crosswise, 5x times 4 is 20x, plus 1 times 3x is 3x. So 20x plus 3x is going to give us 23x. Plus 4 times 1 is going to give us 4. And this is our answer for number 3. So pretty much they're correct. Okay. Now, this is the last part of our exercise. What I'm going to do is just going to show you one application. and extending this to trinomials and beyond. So I don't have enough space, but I can try to apply this. Remember our 3-digit method? We're going to apply it here. And then what we're going to do is we're going to multiply quantity 1 times 1 plus x squared times the quantity of 2 plus 3x plus 9x squared. So let's do it here. So I'm going to need a more space here, plus x squared. We have 2 plus 3x plus 9x squared. So let's apply I hope you can still remember our steps in the 3-digit method. I'm going to refresh you with that. Here it is. Step 1, step 2, step 3, step 4, step 5. If you want, you can take a screenshot of that and then we'll apply it here. Okay, pause the video, take a screenshot, and then let's go back here. Let's apply it. So step 1 is 1 times 2. That's going to give us 2. Step 2 is the first crosswise. 1 times 3x plus x times 2. 2 times x is 2x. 3x times 1 is 3x. So 3x plus 2x is going to give us plus 5x. The middle step, which is challenging. 1 times 9x squared. Let me write it here. 9x squared. X times 3x is going to be 3x squared. And x squared times 2 is going to give us 2x squared. So they're all like terms. So what is 9 plus 3 plus 2? That's going to give us 14. That is 14 plus 14x squared. Next is x times 9x squared is going to give us 9x cubed. And then 3x times x squared is going to give us 3x cubed. So 9x cubed plus 3x cubed is going to give us 12x cubed. And lastly, x squared plus 9x squared, x squared times 9x squared is going to give us positive 9x to the 4th. If you want, you can rearrange that, but it's okay with me for this. Okay? So that's our answer. That's how it works. 2 plus 5x plus 14x squared plus 12x cubed plus 9x raised to 4. And that's our answer for this part in algebraic applications. Okay, and that's it for our general part of the Vedic Maths Essential. In the next video, I'm going to apply. I'm going to give you the bonus content as promised. What is our bonus content here? That is making use of this Vedic Maths Essential. So we're done with subtraction using all from and the last from 10. We're done with the bar numbers. We're done with general case subtraction. We're done with the multiplication by nines. We're done with the vertically and crosswise multiplication just in this video, and we will also show the algebraic products making use of this video. The bonus content will be this: application and analytic geometry. What I want to show here is I want to showcase that Vedic maths is not only applicable in arithmetic and algebra. I want to show you all of the viewers out there that the Vedic maths can be applied in the whole of mathematics, even though in advanced kinds of maths. So that is one way to show you is we're going to show its application in algebraic geometry or analytic geometry. So be with me here. Next video, I'm going to show you that to you, and see you in the next video. Okay, thank you for watching, and pretty please see the next video, which is the application and analytic geometry. You will be surprised by the application of Vedic maths. So again, thank you for watching. Hope you'd like and subscribe, and see you in the next video.